equal to I square or T. What is I actually? I is nothing but current, electric current value. Generally current will flow, no? And current will be measured by which unit? Priscilla? Electric current is measured by which unit?
Ampere.
Very good, ampere. Unmana. So whatever ampere value you are having, that value you have to substitute here. I is a flow of electric current. R is what? Resistance. And what is T? Time of flow of that particular electricity. Okay, is it clear now?
So what is the full form of I?
Electric current. I is electric current. R is resistance. T is time. So in this generally, whenever you are taking any device, I will remain constant for that particular device. That means it can draw some amount of current. And T means the time of flow. If it flows for larger time, more heat energy will be produced. And if less time, less heat energy will be produced. And apart from that, it will depend upon resistance also. And that's why only in previous class I told you to produce heat energy we use some kind of a material which will have very high resistance. And maybe I told you in electrical heater, that means in electrical stoves, we use what? Nichrome. One material will be there. Nichrome material will be there, and that material we have to use. Why we use nichrome? Because nichrome is an alloy which will have more resistance, and when more resistance is there, more heat energy it can produce. So electrical heaters or general electrical stoves, some wire will be there in it, heating element will be there in it, and that heating element will be made with nichrome material. Maybe that also I explained in that previous class, isn't it? Priscilla, I explained or not?
Yes, sir. Thank you.
Right. Okay. Now, so if resistance increases, heat energy increases. Right. After learning about heating effect of electric current, we learned about next one. What is the next one? Chemical effect of electric current. Isn't it? And in a chemical effect of electric current, we learned about electroplating. What is electroplating? Anyone tell me? Electroplating.
The method of plating one type of over another by means of electricity is called electroplating.
Okay. Arna?
Yes, sir.
Tell me, what do you mean by electroplating? Electroplating.
Sir, I don't know.
You are there in previous class or not?
I was there.
Huh?
Sir, I can't recall.
Okay, Priscilla?
Sir, like electroplating is process where two metal elements are taken, and
Okay.
one element is put on the other like a layer.
Okay.
Um,
So your concept is correct, but you have to say in a proper way like this. The deposition of one metal over the other metal is called as what? Electroplating, as Unmana said. Okay. The deposition of one metal over the another metal is called electroplating. And generally, where we use electroplating? Electroplating will be
the
used in
jewelry.
very good jewelry. That means for a decoration purpose we use. Apart from a decoration, for what purpose we use this particular electroplating? Not to get rust. Maybe you know that if we use iron, general iron, for a large number of days, if you keep in air, what will happen? It will be rusted. So to get rid of that rust or to protect it from rust, what we use? Electroplating we use. So these are the generally uses of electroplating. So that electroplating we learned in a previous class. And maybe you know that when electroplating occurs, generally we take one kind of a solution which is called electrolyte. And maybe I told you electrolyte sometimes will be there in the form of a paste or some solid form, semi-solid form, and sometimes it will be there in the liquid form. But in case of electroplating, it will be there in a liquid form. And if two rods are inserted into that liquid, and those two rods will act like a anode and cathode, and when electricity passes through it, generally what happens is that electrolyte will be disassociated. Generally, suppose if we are taking an electrolyte like sodium chloride, it is, you know that it is an ordinary salt solution, and if electricity passes through that particular sodium chloride solution, which is an electrolyte, generally what happens is sodium ions, chlorine ions will form. Sodium generally will become plus ion, chlorine will become as a minus ion. And ions means what? Having excess number of electrons or having deficiency of an electron. If electron is acquired by it, it will become negative. If electron is lost by it, it will become positive. So what happens? Positive and negative ions will form when electricity passes through the electrolyte, and this process will be called electrolysis. What this process will be called? Electrolysis. By using the electrolysis process, we do electroplating. Okay. Is it clear?
Yes, sir.
Okay. So that electroplating we learned, and today we are going to learn first about magnetic effect of electric current. And after learning about the magnetic effect of electric current, we are going to learn about the rest of the things, and after that we are going to start a new lesson today, and that is I will say at that time, but let us learn about the magnetic effect of electric current. And to understand about magnetic effect of electric current, what we do is, let us take one nail or something like conductor. What we have to take? One conductor. Generally, you know that what is the best conductor which is available in our daily life? Priscilla, what is the best conductor?
What we just said. So can you repeat the question?
What is the best conductor which is available in our daily life?
Copper.
Very good, copper. Okay. Now suppose I took copper rod, and here in this particular diagram also, this is the copper rod. Okay. This is copper rod. And for that copper rod, what we do is, let us join that copper rod to a electric cell which is not given in your diagram. And if it is connected to the electric cell, then generally what happens? Tell me. If you connect it to the electric cell, what happens? Bhavya, Kriti?
Yes, sir.
Can you repeat?
Sir, can you repeat the question?
Okay. Now electric rod, sorry, copper metallic rod is there, where I kept one right mark. So like that one copper rod I took, and that to that copper rod, what I did is, I joined that copper rod to a electric cell with a connecting wires. Generally what happens?
Sir, the current is produced.
Very good, current is produced. That means current will flow through the
Copper
rod or not?
Yes, sir, it will flow because copper is a conductor.
Very good. Copper is a conductor. Because of it, the current flows through it. And when current flows through it, then generally what you do is near to that copper rod, let us take one small iron rod or iron nail close to that. When you take an iron rod close to that, generally what happens is that iron nail or iron rod will be attracted by this copper rod. Iron nail or iron rod will be attracted by the copper rod. Why this particular copper rod will attract the nail, iron nail? Priscilla? Why copper rod will attract it?
Sir, attract what, sir?
Iron nail. Suppose if I take one iron nail near to this copper rod, when current is flowing through it, then what happens? That iron nail will be attracted by the copper rod. Why it will attract?
Because of the magnet.
Right, because of the magnetic effect. That means whenever electric current is passing through the conductor, then what happens is around it magnetic field will be produced. What field will be produced? Magnetic field will be produced. That means magnetic effect will be created. And if magnetic effect is created by the electric current, that particular effect will be known as electromagnetic effect. What it will be called? Electromagnetic effect. And have you seen one movie which is somewhat 3-4 years back, a Robo movie? Have you observed? All of you?
We didn't see that.
Okay. And in that Robo movie, what will be there is one robot will be there. He will be like a man only, human only, but he is a robot. And what he do is, he will switch on the electromagnetic mode. And when he switch on the electromagnetic mode, some villains will come, they will take a sword and gun like that. All are made with iron material. So like that weapons will be there. And when he switched on electromagnetic mode, what happens is all those iron, whatever weapons are there, they will be attracted by it. So it is shown in that particular movie. That means whenever any object is behaving like an electromagnet, then definitely it will attract the iron-like objects. So here also, whenever electric current is passing through the conductor, around it, what will produce? Magnetic field will produce. And that magnetic field, whatever is produced, can be detected or can be known by placing one compass near to this particular iron rod. Do you know what is a compass? Magnetic compass.
Yes, sir.
Yes, sir.
Tell me what that compass will do.
Sir, the compass basically towards they say that towards the poles, the north pole and the south pole, they are magnetic poles. So the magnetic compass will have a magnetic needle in between inside it, which will turn to the needle will turn towards the magnetic poles, the poles north and south, and it will indicate the which one is north and which one is south, and it will tell us the directions.
Okay. So magnetic compass generally will tell us about a direction, north and south pole, isn't it? And generally, if you take one magnet near to the compass, what will happen?
Sir, it will keep on rotating.
It will turn towards it.
Priscilla, tell me.
Sir, the needle will keep on turning.
Needle will keep on turning. That means needle will be deflected. Isn't it, Arna?
Yes, sir.
Right. That means whenever magnet is kept near to the magnetic compass, the needle which is there in that particular compass will be deflected. That means it will move. So similarly here what we do is, let us take a copper rod and let us connect it to the electric cell. And when electric current is switched on in that, and if you place one compass near to that particular copper rod, then what we observe is that compass will be deflected. And when compass is deflecting, what do you mean by that? Some magnetic field is produced in that copper rod, and that is due to what? Electrical flow. So in this way, we can understand that magnetic effect is created by the electricity, and this is called electromagnetic effect. Okay. And here in this diagram, observe carefully. Current is flowing in the downward direction first. Observe carefully there. Current flowing in a downward direction or not? In a first diagram. Right. When current is flowing in the downward direction, observe carefully. Now, whatever the circles are there, what these circles will tell us? Circles will tell us that around that particular copper rod, magnetic field is produced. And the direction of that particular magnetic field can be known by one particular rule. And that rule will be called thumb rule. Sorry, what it is called? Thumb rule. By using the thumb rule, right hand thumb rule, what we can do is we can find out the direction of the magnetic field, in which direction magnetic field will be there. So to show that, only two diagrams were given for you. If current is flowing in the downward direction, circle arrows are shown in one direction. And when current is flowing in an upward direction, the whatever magnetic field which are circles are there, the direction of them is in different way. So the direction can be known by which one here? Thumb rule. So now once again tell me, whenever electricity passes through any conductor, what happens?
Behaves like a magnet.
Okay, it behaves like a magnet. That means magnetic field.
A magnetic field is created.
Very good. Magnetic field is created around it. And you can test it by placing one compass. If compass is deflected, magnetic field is there. If compass is not deflected, magnetic field is not there. So you can do that experiment. And if we do that experiment, compass will be deflected. Thereby, we are saying that magnetic field produced around it. And the magnetic field which is produced around that particular conductor, the direction of it can be known by using which rule? Thumb rule. Okay. By which rule we can know the direction of a magnetic field?
Thumb rule.
Right, thumb rule. Right hand thumb rule will be there. And you take your right hand. All of you. You take your right hand. Are you doing? Priscilla.
Yes, sir.
Right. Everyone take your right hand and first stretch your thumb upwards and you curl your fingers. You curl fingers. And when you are curling your fingers to close it, in which direction you are closing the fingers, you are curling it. In that direction, what will be there? Magnetic field will be there. And now examine in a same manner. Let us keep thumb to the downwards. And now curl the fingers to close it. With the same direction you are closing or in a different direction you are closing?
Same direction.
Priscilla, once again check. First you keep thumb upwards and close your fingers. Okay, have you tested? Next, keep your thumb downwards and close it. When you are closing, direction is changing or not? Check once.
Yes, sir.
Right. So generally thumb you have to place in which direction? The direction of the current which is flowing in the conductor. That means in a first case is there or not here? This first case is there. For this you have to keep thumb down as electric current is passing through it and you close your fingers. Then which direction the you are closing the fingers, in that direction magnetic field will be. Okay. And for a second case, you keep your thumb up and close your fingers. In which direction you are closing the fingers? In that direction, what will be there? Magnetic field will be there. And this you have to remember. I may ask you this question in your examination and you have to give the answer accordingly. Okay. Is it clear? Priscilla, is it clear?
Yes.
Have you done that? Thumb placing like this and down up.
Yes, sir.
Okay. Arna?
Yes, sir.
Arna?
Yes, sir.
So have you did that particular thing which I said?
Yes,
Keeping
so
thumb up.
all it happens in the same direction.
Okay.
I think I
Yeah.
can.
You are getting same direction, Arna?
Yes, sir.
How? First you keep thumb up. Close your fingers. You are getting one direction, no? Circular direction you are getting or not?
Sir, I didn't understand.
So can you show the previous slide?
Previous
Yes.
slide. Okay. Right. In this particular downward direction is there and you are closing the fingers like this, no? No, actually I have to draw the diagram, but let me draw here. Now this is electricity passing through this in this direction. And now you are closing the fingers like this. So when you are closing the fingers, you are closing in this direction. So current will flow in this direction. Okay. And when current is flowing up like this, then what happens is the magnetic field producers will be there in opposite direction like this. Sorry. In downward direction like this will be there. Let me draw again. If downward direction is there like this, magnetic field will be there like this. And in this direction magnetic field will be, you are closing the hands like this. I can show it, but here this particular video will work or not, I will see. And if it is possible in the next class, I will show you how I am closing the fingers and how I am opening the fingers like that. I will show it in a next class and I will present it. Okay. And thumb rule you can understand by that particular whatever activity is there, right? Okay.